Right, in this video, we are going to cover some brain training exercises that will help you let go of your calculator and basically become your own capable numerical solving machine. It takes a couple of mental understandings, things that we're going to learn. Right? Once you see these and you do practice them and use them to your advantage, by the time you decide to pick up a calculator, you're going to be doing them in your mind. So it takes practice, it takes plenty of trial and error, and doing this exact process on your own, on paper. You have to do these. So, watching this, I'm going to really speed through it, but I want you to take the time and practice these whenever you are uh, on your own, maybe do it in your head. Now, in the end, that's like the most useful way to do this, especially when you're like watching an advertisement or something on the YouTube. If you want to just turn off advertisements, do a couple of these exercises. Now, the biggest thing to know is we are really going to be focusing on PEMDAS as the root of our focus. We know PEMDAS, we know what it stands for, but let's just go ahead and do it here. We got parentheses in order, exponents, multiplication, division, addition, and subtraction. There are patterns in these operations that we can use to our advantage. For instance, one of the main patterns is that if I have a repeating number that's being added over and over and over and over again, we can consider this to be a long form of adding multiple values. However, when we look at multiplication, it comes in with a shortcut. Mathematicians are lazy. We have shortcuts all over the place, and by knowing these shortcuts and practicing one of the simplest of forms, you get to master the next level. In this case, mastering addition will help you understand multiplication and do it much faster. For instance, what happens when I have these pieces together? Well, we will shorthand it to saying I have four copies copies of the number 3. So what is 3 plus 3 plus 3 plus 3? It's 12. What's 4 times 3? It's 12. We'll notice the pattern. Multiplication can be condensed into a shortcut of addition can be condensed into a shortcut of multiplication. So how do we get our multiplication to be perfect and be capable of essentially doing it in our head when we're doing multiplication? Well, we're doing addition in smaller forms over and over, which now we go to skip counting. The exercises to essentially get skip counting or multiplication to be fully independent of a calculator is really going to be practicing all of the first 10 skip counting numbers. Ones, there's not even a skip there. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we don't have to really do anything there. However, twos, obviously, we can practice those if it's necessary. If it is, go ahead and practice, but try and do these in the fastest way possible. So this here is an exercise you can do at any time to help you calculate much faster. So we start off with 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Boom. Nothing crazy here. And I will show you a pattern that comes up from this once we get to the final piece. Then we go to our threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. We keep going. We keep practicing these numbers in skip count form. So we're skip counting now by 4, 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. And then 5, 10, 15. This is normally the easiest for most to remember. 25, 30, 35, 45. Oh, look at that. Going so fast. I skipped one. 40, 45, and then 50. 6, 12, 18, 24, 30, 36, 7, 72. That's 6 times 7. 42, 6, 7, 48, 54. I'm sorry for that. 60. I've been teaching a lot of K to sixth graders, and I cannot get away from that meme. 7, 7, 14. One of the hardest ones to master, especially when going over the actual tens, right? The 10, 20, 30s. Anytime we go from 28 to a 30 something, that's when some kind of complications can happen. But here's a trick that can help you with not only the small pieces of adding or going over, but let's say we are going to apply this shortcut, this mental exercise. If we need to add a 7 to the next value, what I can do is add the 5 to get to 40, and then 5 plus what is 7, or take the 5 we just added and subtract it from the 7, and then you will get 2 left, bam, 42. So there is a small shortcut that can help you just get to the next checkpoint. And then with that, those checkpoints are always zeros, so you find what's left over to get the 7, which is a 6, and you have 56. This essentially is one of the biggest speed ups you can do in order to count over. Now, this is not just valid for small numbers, it's valid for any set of numbers if you also consider splitting them into tens, ones, and hundreds and smaller portions when you do addition, the mental math that we try to practice. Then we got 18, 16, 24. 32, 40, 48, 56, 64, 72, and 80. And finally, 9, 18, 27, 36, 45. Some students will notice that for these, the ones go down and the tens go up with each incrementing value. Did you catch that? 3 goes up by 1, becomes 4. 6 goes down by 1, becomes 5. 4 goes up by 1, becomes 5. 5 goes down by 1, becomes 4. And repeat. That's another shortcut, specifically for the nines. Don't take that one to heart, but it does definitely help really count by nines much quicker. But also the shortcut with our checkpoints can also help us when we're going over any sort of tens checkpoint. The tens, the 50s, the 40s, the 30s, whatever we're going over, we can always use that as a quick mental split of the number we're trying to add. In this case, it was the 7, and that 7 just splits with 1 to get to 50, and then 6 to get to 56. Very, very straightforward, but you can use when you're doing mental math, and it can help you with the values. Now, for the record, most of these will be fine for most students, but you are really looking at practicing 7, 8, 9, potentially 6 for some, but doing this over and over can give you access to what we will see on the bigger pattern. Let's add our ones now. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If you haven't noticed it yet, check our 5 column. We have replicated the same 5 values, 5, 10, 15, 20. And also a good place to start for many cases is the 5's column. For this, what we can really do here is really understand that when we practice skip counting, we are practicing multiplication, or at least the discovery of multiplication as we are doing the actual multiplying. So let's say we do something like 7 times 8. What can we do? We can start at potentially, well, we can start from the beginning, in our case, 1, and then count it. 2, 14, 3, 21, 4, 28, 5, 35, 6, 42, 7, 49, 8. And of course, having these two numbers in mind, it's recommended just to count the 1, 2, 3, 4, 5s with your hands. You have 10 fingers that helps out in the skip counting. And then just recalling the 7, 14, 21, 28, 35, 42, 49, 56. And when you see 8 fingers, you know you've gotten to the 7 times 8 location, which would be 56. However, that's not that great of a shortcut. You know what is? That highlight I did. Remember that when you do this, not only do you master a specific value like fives, which is not that hard to master, you're just counting by fives and zeros. What you're really doing is giving yourself a later starting point, like 7 times 5 is equal to 35, and then moving forward with 7 times 6, adding a 7, and as you know, you're multiplying tables, you will build yourself forward to that 56. You can also start it backwards. You don't necessarily have to begin from the top or from the beginning of our values, although you can. So you can get there like this, or you can reverse that process by starting at 10. That's a nice one also. And instead of adding, you're subtracting 7 backwards, and you're just moving backwards if you're good with subtraction. Now, subtracting and adding is going to be really dependent on the skip count. Once you master the skip count, you can master these next order of operation checkpoint movements, starting at 5, going up and down, or starting at 10, going up and down. And really, in the end, you don't actually have to memorize much other than all the fives, all the, well, obviously ones, it's just one, and the tens. And then being familiar, you don't have to memorize. Again, just being familiar with the movements, the subtraction and adding, you can move back and forth in between any of these columns. And these are the easiest, obviously. We probably don't even have to do these on the left, but it's the right columns that are the harder ones. So starting from the tens or the fives can help us move and subtract or add from either direction to find any number in between. So that is one of the main strategies that I like to provide for my students. Master your skip counts, and then master moving around the checkpoints, all the fives, all the tens, and whatever values that you can start with that'll give you a faster movement over. And when you do this, you essentially don't have to pick up a calculator. In 5, 10 seconds, you'll be able to get the answer without having to type anything. And when you practice this and the faster you get, well, the more independent you become in calculations as well. So that's one of the base, fastest, easiest ways to essentially think about the movements. I'll add in a little extra here, considering that addition and subtraction are opposites. We've just used them to move across our multiplication table. We use them either from an upper value like 70, and we move backwards to get to our 56, right? Or, sorry, this one was an addition. We subtract here. Or we use the fives and move forward to get to our 56 by just adding. So this is another way that we can really depend on PEMDAS to show us a little bit of guidance and versatility when we're doing calculations in arithmetic. The other case is to understand that once you master multiplication, through this process, you also master division. They are also siblings, just like addition and subtraction, opposite siblings, and multiplication division, also opposite siblings. But remember that little shortcut I showed you where we are actually taking addition and changing it into multiplication? Well, this kind of gives a even more broader perspective or broader relationship, more like a cousin type family relationship, where two families, addition, subtraction, have their own rule and their own household, and both brother, sister, opposites, or siblings, opposites, are having to abide by certain rules. Then multiplication, division also have their own rules in their household. However, addition and multiplication do have a nice relation as well, a very much shortcut based. Can I do it faster with less writing shortcut? And this is again how mathematicians Anyone that does mental calculations really benefits from these shortcuts because in the end, we're lazy. We like to get to the number answer, the final value faster. And knowing these shortcuts, you do get that mentality to just zoom through all the values without having to do any crazy math on the side. And there are higher level adding, subtracting, uh, shortcuts that you can do when you're doing double digit addition or triple digit or quadrat quad digit, whatever extra digit. Those are specific to just multiple digits in a single value. So anything from the 10 shortcut, 12 plus 18, etc., will work with 120 and 180. So knowing a little bit about those shortcuts, we'll get to in the future. But this really does set you forward to understand and work with a very, very smooth starting process to being really good at numerical crunching. And by the time you do pick up a calculator, you'll basically be done in your head. And honestly, what's better, having to depend on a device that has a battery or your brain that's right there and ready to go? And make sure you like and subscribe, guys, for more tips on mathematics, programming, servers, Linux, gaming. If you'd like to join my Patreon and support me, you can do so for free. If you do want further help and further guidance, because there's a lot of tips that I have essentially found very helpful with my students for over 15 years of tutoring and teaching and mentoring and doing all kinds of one-to-one and group project, group workshops, and all kinds of different ways that we can help students really benefit from these little brain training exercises. So make sure you practice this if you want to get better in your mathematical calculations, whether it's for school, whether it's for work, whether it's just to get your brain to really start exercising. Because what we are doing here is brain training. You are in the brain gym of the super scholars, all right? We do a lot of mental exercises here, whether it will be logical, calculative, or even philosophically mental twisted sort of conceptual ideas. And they all help the mind think from two different perspectives, from the logical side and from the creative side. Thinking outside the box, but using the box's rules to maintain order. So within this, I hope you enjoyed this video. I hope you found it helpful. And make sure to like and subscribe for further videos. Hit the notification when I go live. And you can ask questions on any live. I do definitely promote anyone coming in, asking a question about anything, whether it's mathematics, programming. I like to keep it based on the subject of the live, but sometimes I just have a free for all where I'm just chilling, waiting for my sessions and maybe playing a game. Once I get the attention, once I see the chat, it may take a little bit, especially if I'm playing, a little bit of a focused mindset. But once I see, I will help you out and we can talk about anything that you'd like to go over. So thanks for watching and hope you have a good day. Bye.